Good morning or afternoon. How are you doing? Um, Today we are on the second part of chapter 15, where we're talking about our atmosphere. We are going to talk about the atmospheric layers or the layers in our atmosphere today. By the time we get done, you should be able to list the major layers of the atmosphere and their temperatures. You should be able to discuss why all weather takes place in the troposphere, and to be able to discuss how the ozone layer protects the surface from harmful radiation. So we have to start with gas molecules, and because that kind of is what our atmosphere is all about. We know that in our atmosphere, the air density and the pressure changes as you go farther into our atmosphere. The molecules move farther apart. So because there's less gravity pushing down on them, so those molecules move farther apart. The other thing is when gases are cool, molecules don't move so much, so they're closely compacted and closer together. When they're warm, the molecules move a lot, so they spread out and density and pressure are low. Now that sounds weird, but it's what happens. Because warm air is less dense than cold air, warm air rises and cold air sinks below it. If you were in my classes in 7th grade, you remember I went over and over and over again about convection currents. That's because convection currents are all over our planet. Remember, we've talked earlier too this year about warm air is less dense. The particles are moved farther apart. So because it's less dense, it rises. And as it rises away from its heat source, it cools down. Then those particles all start to come back together because it's cooling. And then the cool air sinks back down to the heat source where it warms up again and starts to rise again. Remember, that is called a convection current. And if you don't learn anything else in this chapter, you got to learn convection currents. The change in density and pressure are consistent with our altitude in the atmosphere. That means that it's as you go higher up into the atmosphere, the density and the pressure both decrease. It's not a back and forth, it's going to decrease because those gas particles are going to move farther and farther apart because there's not as much gravity pushing down on them. However, the changes in temperature with altitude are not consistent. If you look at this picture over on the left of your screen, you will see that they kind of go back and forth and back and forth. Our layers of the altitude are based on what happens to the temperature in the altitude. Changes in temperature with distance are called a temperature gradient. So in some layers, that temperature gradient is an increase, and in some layers, the temperature gradient is a decrease. You can see that on this chart. Layers of the atmosphere, in case you don't know them, are the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. The layers are based, again, on what happens to the temperature in each layer. Now, there's stuff going on, different kind of stuff going on in each layer that we're going to talk about. So we'll start with the troposphere or the troposphere, depending on who's pronouncing it. It is the layer that is closest to Earth. It's the one that we know most about because, again, it's closest to us. Temperature in the troposphere, lowers as altitude increases. So the average temperature by the surface of our planet the average temperature is about 60 degrees. And then as you go higher and higher at the very top of the troposphere, the average temperature is negative 76 degrees. So that's quite a difference. Earth's surface is the source of the heat in the troposphere. Air density and gravity cause the temperature to be higher at the surface, and it decreases as you go up. Again, because of Earth's surface is the heat, that's why it's hotter down close to us. All weather is going to occur in the troposphere, and it's caused by that convection current, that mixing of the hot and cold air. Sometimes, especially during cold weather, you can see cold air will slide underneath the warm weather because the surface is a little bit colder. This is what we call a temperature inversion. Temperature inversions happen it can be a short period of days, sometimes it's weeks. It's not going to be for forever. The air in the inversion is very stable because that cold air wants to be underneath the warm air. Because cold air is more dense, it wants to be down there at the bottom, and warm air is less dense, so it wants to be at the top. So when it gets that way, it tends to stay that way for a longer period of time than it would if you had the convection current at that moment. The air in the inversion, because it's stable, it's not mixing around so much, so it can trap pollutants down close to the surface. You see this a lot in big cities like in California, the Los Angeles area. That's where you get a lot of smog, and it gets stuck there for a long time. Between the troposphere and the stratosphere is a really calm layer because you have the cold part of the troposphere and the warmer part of the stratosphere. Temperature doesn't change with altitude because the cooler air of the troposphere is trapped there underneath the warmer air of the stratosphere. The air doesn't mix. It just stays there between the layers. It doesn't mix much. Then we get to the stratosphere. It's the next layer. If you look right here, it shows that the troposphere, you see the temperature decreasing. Then you have the tropopause, and then the stratosphere. You notice that the temperature increases as you go up in the stratosphere. So it can go from a whole negative 60 degrees to negative 5 degrees. The warm air is going to stay above the cooler air, making this layer really, really stable. There's not a lot of mixing of the air there. The heat is going to come from the sun. And it's going to be really close to the ozone layer, so it's going to stay nice and toasty warm there. Toasty warm at negative 5 degrees, by the way. The ozone layer is part of the stratosphere. It's in between 9 and 19 miles or 15 to 30 kilometers altitude. The ozone layer is really, really important to us because the ozone gases in the ozone layer are what absorb the ultraviolet radiation from the sun. That ultraviolet radiation is what causes us to have cell damage in our skin when we're out too long. Even though we have the ozone layer, we still get that cell damage if we're out in the sun too long. We call it a sunburn. But if we didn't have the ozone layer, it would be more than just a sunburn. We would basically cook, because we would not have the sun's ultraviolet radiation would damage all of our cells really quickly. The next layer is the mesosphere. It's the middle layer of Earth's atmosphere. The temperature in the mesosphere, again, if you look over here, you can tell it decreases with altitude. So it's going to go from between -5 to -184 degrees Fahrenheit, not Celsius. Heat source from the mesosphere is the energy that comes from the stratosphere. So it's not getting a lot of heat. That's why as you get farther away from the stratosphere, the temperature is going to go down. In the mesosphere, the air density and the pressure are really, really low. The gas molecule, the gas molecules have moved really far apart. There's not much gravity on it, so there's not much holding those molecules together. It's above the ozone layer, so the radiation levels are really, really high. There is no oxygen in this layer. At this point, the oxygen is gone. And we would die if we were to get into the this area because of oxygen deprivation. Temperature increases in the thermosphere with temperatures that range between 184 down close to the mesosphere and over 3,600 degrees as you get closer to the exosphere. Heat comes directly from the sun. There is no protection there. So the density and pressure in the thermosphere is very low. Molecules are really, really far apart. Very little energy exchange here. But there's also no protection from the solar radiation here, which is why the temperature it gets to be so high in this layer. The ionosphere is part of the thermosphere. Solar radiation splits gas molecules to create a positively charged ion and at least one negatively charged electron. These hang out mostly in the Van Allen's belt. There are where there are two kind of donut oval shaped zones of highly charged particles. That this is just beyond the atmosphere in the magnetosphere. The particles in that Van Allen's belt come from that solar radiation with the solar winds. Solar winds are what kind of blow that radiation around. Sometimes those belts get really, really overloaded with particles, and the particles then excite the nitrogen and the oxygen particles, which is what really lights up the northern and southern skies in what we call the auroras. There is an aurora aurealis and an aurora borealis. This is what they look like over here. They're really beautiful because oxygen and nitrogen both make different colors when their particles are excited. So you get all kinds of different beautiful color swirls in the auroras. The outermost layer of Earth's atmosphere is the exosphere. There isn't a real outer limit of this atmosphere, of our exosphere, because the molecules just move farther and farther apart until they're just ridiculously far apart. In the exosphere, molecules can be up to a whole kilometer apart before you run into another gas molecule. So there are 4 gas molecules. That's a really long distance. Beyond our exosphere, we have space. Particles fly out in space from the sun at really high speeds. This is what we call the solar winds, and this is what we were talking about a little bit earlier. Those particles move really fast, and it's mostly protons and mostly electrons. And that's all we have for today. You needed to know the layers and a little bit about each one of them, and so that's what we've done. If you have any questions, don't hesitate to shoot me an email. Make sure you watch all of the video. We are halfway through the chapter. We will have another section on Wednesday and Thursday, then again on Monday and Tuesday, and then the test over this chapter will probably be Thursday or Friday of next week. So be sure to make sure that you understand everything that we're going over. Have a great rest of the day. Bye.